to section 2.1 here. Before we're done with that. So, in just a brief overview of arc function stuff. So our arc functions are also known as the inverse trig functions. And again, the goal of these arc functions are, you give it a value less than 1, depending upon which arc function you're working with, what it's going to do is it's going to return to you an angle or a arc length that goes along with our unit circle picture for those particular values. Now, what we have to remember are the domain and ranges are going to be limited based on the arc functions we're working with. And so we'll do the ranges and domains here again just to refresh ourselves. Arc sine. I'll throw in the arc tangent one as well. And then we'll just leave it with those three for now. Arc cosine. Remember, the arc cosine has to be defined for the output values of the cosine function. What values come out of the cosine function? What numbers do we get out of the cosine? Right, the values we get out of the cosine function are anything from positive 1 to negative 1. So our domain for the arc cosine is minus 1 to 1. Okay. All right, now we need to think about the range. All right, the range of the arc cosine function is going to be the input values that we're allowed to use for a cosine function. But we need to remember we're only allowed to use part of the cosine function because we want our functions to be, we need a one-to-one function in order to have an inverse. And so when we're working with the arc cosine, we're only restricting ourselves to the portion of our cosine graph that looks like this. What are the x values that go along with this picture? We go from all the way from 0 up to pi. So our range here for the arc cosine is from 0 to pi. Again, remembering that the arc cosine takes values between minus 1 and 1 as inputs, and it spits out an angle between 0 and pi. All right, what about for the arc sine function? Again, what are the values that we get out of sine? What numbers come out of the sine function? Right, the sine function gives us values between negative 1 and 1. Now, what kind of values do we get out of the arc sine function? We come in here, we look at the portion of the picture that we're allowed to use for the sine function to be 1 to 1. What are the values that go along with that picture? Right, we're working with negative pi over 2 to pi over 2. Okay. And then finally we get down here to the arc tangent function. We haven't talked too much about the tangent stuff, or the arc tangent stuff, even less. But again, we want to try to figure out what values can I plug into the arc tangent. Well, let me draw a picture of the tangent function, and then we'll use that to decide what our domain and range needs to be. All right, so this is part of the tangent graph, the graph of the tangent function. Again, I didn't complete it all the way, but it continues on in each direction forever and ever like this. I need to first identify what values do I get out of the arc tangent function, the tangent function. What numbers, what y values do I get out of this picture?
Oh, infinity.
Notice in this particular picture, this graph continues on forever in both the positive and negative direction. Okay? So outputs of this function are any number whatsoever. So the outputs of the tangent function are minus infinity, positive infinity. How does that relate down here to our tangent function? Well, that's the domain of outputs of the original tangent are the inputs for our arc tangent. Now, in order to have an inverse function, our tangent graph has to be 1 to 1. Where do I need to restrict myself to in order to make this graph a nice 1 to 1 graph? The best thing to choose here would be from negative pi over 2 to positive pi over 2. Now, looking at the graph here, do I include minus pi over 2 and positive pi over 2? I don't, because those are not actually values that I'm going to get answers from the tangent function for. So, in this case, my range is negative pi over 2 to pi over 2, open parentheses on each end. Okay. All right. So, what's that? Why the open parentheses? Because what value do I need to plug in to, or two ways to do this. Can I actually plug pi over 2 into the tangent function? Why not? Because it's not defined there, right? It's undefined at pi over 2. Why? Because if you remember, tangent is sine over cosine. Okay? What's the domain of this function? What am I allowed to plug into tangent? Well, I can plug anything I want into this as long as I don't divide by 0. Where do I divide by 0? This, and every other odd multiple of pi over 2. So that's why I don't include them here as part of my ranges, because they're not part of the original domain. Okay? All right. Good question.
Since you couldn't use 0.
Can't use 0. When you say can't use 0, what do you mean by that? I can't let cosine equal 0. Okay. I can use 0 because cosine of 0 is 1, and so that's okay. I just can't let the whole bottom value be equal to 0. Okay. All right. So, domain and ranges of these arc functions. There's similar sort of things you can go through to get domains and ranges for arc secant, arc cosecant, and arc cotangent. I'm not going to worry about those too much right now. If you have the ideas down for these, you can work the ideas for the other ones without a problem. Okay? But arc functions, they take numbers as inputs. They take numbers which relate to y values on these pictures, and their outputs are angles that correspond to angles on our unit circle. Okay? As an example, find theta if, and here we'll have some, right? The first one is if sine of theta equals minus square root of 3 over 2. And I should be, well, I'll talk about that in a second. Cosine of theta equals minus 1, and C tangent of theta equals square root of 3. Okay. Now, what these questions are asking me to do is they're asking me to utilize these inverse functions, these arc functions, to figure out what theta is, to figure out an angle. I need to use these inverses to figure out angles to put in for these theta values here. Okay. All right. So, the first one here. What I'm going to do is I'm going to take the inverse sine, or the arc sine of both sides, and what that's going to do for me is I'm going to get something like arc sine of the sine of theta equals the arc sine of negative square root of 3 over 2. Now, arc sine and sine are inverses of each other. So when I compose them like this, what happens? They annihilate each other. They kill each other off. On the left-hand side, we're left with a theta. On the right-hand side, we're left with an expression that we need to evaluate. Okay? All right. We can do the same thing for the other one. let's focus for a moment on how to figure out the answer to this one. Okay? First thing we should do is we should say, all right, does it even make sense to write arc sine of negative square root of 3 over 2? Is negative square root of 3 over 2 a value that I can plug into the arc sine function?
Yes.
Okay? Negative square root of 3 over 2 is in this domain. So I can plug that in. Now, for this domain. Now, I need to figure out what angle has a sine value of negative square root of 3 over 2. If you, we'll come back in just a second. Let me,
Unit circle?
okay, we'll work the unit circle, but let me draw the picture for a second of our sine function. Remember, our sine function is this function that repeats itself over and over and over again. It has this wavy shape like this, and it'll continue on forever. Okay? Since I'm using this arc sine function, the arc sine function is only going to give me out an angle within those two vertical lines. Okay? Here's my minus pi over 2. Here's my pi over 2. There are lots of angles which have a sine value of negative square root of 3 over 2. There's lots of them. There's an infinite number of angles whose sine value is equal to negative square root of 3 over 2. The method that we're using to find an angle is only going to give us a value that is in this area right here. Okay? So we need to make sure that we recognize that. The answer we're going to get here is only in this region. If we needed to, we could find it elsewhere, but for now, that's where the answer that we're going to get is going to lie. Okay? So, now we need to figure out what angle that is. So, we can go to our unit circle, and we can try to figure this out. Let's see. The sine value of negative square root of 3 over 2. Which quadrant would that sine value land us in? Should land us in the fourth quadrant, because remember, sine of theta is always the what? X or Y value? Sine is the Y value. And just cosine the X value. Alright, so here our Y value is negative. Because we're only allowed to get angles between minus pi over 2 and positive pi over 2, our angle in this case has to be over here somewhere. So this is where the angle we're looking for is. Okay. And now we just need to figure out, okay, which one is it? Which angle is it that gives us a sine value of negative square root of 3 over 2? We could use the triangle. It's going to be, if we draw the triangle, there's no problem with drawing the triangle. We just have to know how to get from the triangle back to the angle. Which again is utilizing the inverse cosine function, the inverse sine function. Okay. Or we memorize that little table that we gave about what the values of the common angles are. Okay. Square root of 3 over 2 was one of the common angles. That was one of the output values of the common angles. Remember which one it was? It was a 60-degree angle. So down, if our answer lies down here instead,
300 degrees.
okay, okay, this is a good learning experience here. Said 300 degrees. No, it's not.
Always a good learning experience.
Everyone's a good learning experience. Okay. Trey's answer of 60 degrees was a good chance to do a learning experience as well. Because if we come back over here and we look at these values, is 60 degrees in here? Does 60 fall within minus pi over 2 and pi over 2?
Yes.
Does the number 60 show up between minus pi over 2 and positive pi over 2? No. 60 is not in this range right here. Okay? So you can think, okay, I'm going to get out an angle, that angle's in degrees. That's fine. You want to get an angle out in degrees, no problem. This range is in radians. So you better make sure that you're converting back to radians when you're giving your answer. Okay? So, here's you said the 300-degree angle, right? How do I convert that into radians? 300-degree angle is how many radians? It's equivalent to a minus pi over 3.